All right, today we're going to be talking about section 5.4, which is kind of like how do you use trigonometry when we're not in the unit circle, when we don't have that 30, 60, 90. I have a cute little cartoon here for you. It's the fake tan, where in tan it's usually O over A, but when it's a fake tan, it's ooh over ah. Kind of funny, kind of. All right, so we're going to look at finding when you have a point, how do we find the 6 trigonometry functions for that? Or if, and it should say remaining 5 trig functions. I don't know where I'm getting 4 of trig functions. It should be remaining 5 trig functions given one of the trig functions and the quadrant. Or how do we solve right triangles? So there's 3 really important topics. All 3 will be on our exam where we're going to be assessing on that. So let's look at this. Find a coordinate point. When we're given a coordinate point, let's find the 6 trig functions. I'm going to go in a little more. I'm going to zoom in here. I hope you're okay with this for a minute. There we go. A little bit better. It gives us just more of the screen to see. So the point we're at here is the point 4, 7, which means you go about 4 over and about 7 up. That's how we get to 4, 7. Well, here's 4, here's 7. If I complete my right triangle, and really that's what this is about, it's completing the right triangle. There's my right triangle. Now in this right triangle, I'm in the first quadrant, which means I went positive to the right for the 4 and positive up for the 7. So they're both positive. And we have to kind of calculate the hypotenuse because right away it's sine, and we're always going to be taking, this is always my reference angle, it's the angle that's 200. And so for that I kind of have to calculate what is this hypotenuse here. So I have to calculate it using Pythagorean theorem. So on my calculator I said 4 squared plus 7 squared, and I said what is that? And then I took this, I took the square root of that, and what I got was the square root of 65. Okay, so I know my hypotenuse is square root of 65. I really do want you to leave your hypotenuse, is that more than one hypotenuse? Anyway, in a square root form. Don't tell me the decimal because you're just estimating. I want the actual answer. So now for sine of this particular angle, it doesn't matter what the angle is, it's just saying sine of that angle is opposite over hypotenuse. Be careful that you don't say, oh, I know, no, you know, from unit circle, sine is my y, it's 7. Well, no, it doesn't work that way because we're not in the unit circle. In the unit circle, our hypotenuse is a unit, a single, a 1. It's not that case here. It's a square root of 65, which is definitely not 1. And so we have to kind of say, okay, no, we don't have the rules of the unit circle anymore. Cosine here is 4 over square root of 65. Tangent, opposite over adjacent, ooh over ah, and we have 7 over 4. And cosecant, now I'm just learning to flip, you know, I'm just flipping what I had in sine. So square root of 65 over 7. Secant, flipping what I had in cosine, square root of 65 over, 4. And then cotangent, flipping what I had in tangent, 7 or 4 over 7. I had 7 over 4. Okay, so that's the answer to our first example. Now let's look at our second example of what we're going to do when we're not in the first quadrant. So that's really the only difference here is that we're not in the first quadrant. So I'm going to go here, -3, and then up 2. So there's my triangle. I might make it, we'll leave it the way it is. -3 and +2. Again, I need to figure out what's my hypotenuse. So again, I'm going to go 2 squared plus a -3 squared and say, okay, what does that equal? That's my hypotenuse squared. 2 squared is 4, -3 squared is 9, 4 and 9 is 13. That's what c squared equals. So here is the square root of 13 is my hypotenuse. Okay, now I have everything I need, and I just need to say, okay, here is my angle that I'm talking about. There's my theta, and I just need to go back to what I know. So katoa, sine 2 over square root of 13. Cosine, -3 over square root of 13. Tangent, -2 over 3. Does it matter where the negative is? Gosh, no, not at all. We can put it out in front and we can put it at the numerator. Usually it's just not technically good math to put it in the denominator. Cosecant, I just need to go back to sine and say what's my sine? So that's my cosine, or cosecant, square root of 13 over 2. Secant, negative square root of 13 over 3. I'm just flipping what I had up here in the cosine. Cotangent is -3 over 2. All right, let's keep going here. Now, what happens when we're given kind of what we had when we had a quadrangle? Really very similar. So this is the point here, 0, 5. Okay? So we don't really think of then the hypotenuse. We actually go back to our quadrangle rules when it's on the axes. So the quadrangle rules fit any value on the axes. So the sine is still the y, which here is 5. The cosine still is the x, which here is 0. The tangent still is y over x, which in this case is 5 divided by 0, which in this case you can't do. It does not exist. You can't have that 0 in the denominator. Cosecant, I'm just going up here and thinking of that sign as 5 over 1, so the answer is 1 over 5. Secant, I'm thinking of 0 as 0 over 1, so it's 1 over 0, which does not exist. You cannot divide by 0. Here, on the other hand, for tangent, I'm thinking of it as 0 over 5. Now, 0 over 5 is acceptable. We can say, okay, that's 0. So that does exist, okay? Go ahead and look on your own. I'm going to have you ask you to pause this and try to do this last example on your own. I'm going to pause it and the answer will magically appear. So here is our angle drawn here, and here are our answers. So hopefully you had it right as well, but it's a good chance to just kind of check yourself, make sure you're on the right track. The next type of problem that I want to go over and give you an example of is, what if you're told instead of what one point is, you're given what is one of the trig functions and you're told what quadrant you're in. Now they have to tell you what quadrant you're in, because if they just said 3/5, we'd know that sine is positive, and then we know that sine can be positive either in the first or the second quadrant. So they kind of have to be more specific, or we have to say, well, it could be this, it could be that. So we would have been drawing two triangles. So 3/5 here in our triangle here. There's 3 and I go up 5. And we're in quadrant 2 here. And I messed it up. I did this last time. I apologize. I had the 3 and the 5. I'm going to redo this. All right. So I know I have a triangle here in quadrant 2. And I was told that the sine, however, is 3/5. The sine is opposite over hypotenuse, not opposite over adjacent. I apologize for that. So actually, I have to calculate what is that adjacent side. So now I'm going to take 5 squared minus 3 squared. 5 squared is 25, minus 3 squared is actually 4. Now I kind of have to use some logic too to say, hey, that actually would be a -4, because -4 times -4 would be that 16, which is what we get here. So it could be a remember how what we do here is take a square root, and so it technically could have been a positive or -4. So that line is actually a -4 because of the quadrant that they give us. So now we already have sine as 3/5. What's cosine? Well, cosine is -4/5. Tangent would be -3/4. Cosecant, flip of what they gave us, so it would be, 5/3. Secant would be the flip of the cosine, -5/4. Cotangent's -4/3. Okay, not so bad. Let's look at another one here. So tangent is -5 in quadrant 4. So my suggestion for these, first just draw a triangle. Draw the triangle in the quadrant that we're talking about. There's my right triangle. It always looks like that when it's in quadrant 4. Then think to yourself tangent, and I'm going to think of this as -5 over 1. And actually, I'm not even going to deal with the negatives yet until I put it there. And then it turns out that, yeah, actually the 5 would be the negative and the 1 would be positive. Only one of them needs to be negative in order for it to be the -1 that's up here. So now I have to figure out what's my missing side, my hypotenuse. So I would say 1 squared plus 5 squared, that's 26. And so this answer is going to be square root of that 26, because it's the square root of whatever we have. Hypotenuse is always positive, and I can't emphasize that enough. It's always going to be positive. So then I can quickly go through this, and magically all of the answers appear. And so just check your knowledge, check what you're doing here. I just tried to save some time. All right, next one. Now, one of the things in a triangle, in a right triangle, almost always our C is our 90-degree angle. Almost always. But the triangle is shown in a lot of different ways. But the C is almost always the 90-degree angle, and so we're going to stick to that. The B, really, we could put the B there. We could put the B there. We use capital letters to show vertices. So we're using those capital letters to show the vertices. Across from the lower uppercase c is the lowercase c. So the c is always the hypotenuse. Across from the uppercase a is the lowercase a, the side across from it. So that side there is the lowercase a. Across from the uppercase b vertex is the lowercase b side. That's going to be important because we're going to be assuming that you know that when we give you these types of problems. Let me show you an example. So here in this problem, we're going to say, okay, if b is 48 degrees and a is 13, please find side c. Well, you have to know that when they say capital B equals 48 degrees, that you have, and it really, if you switch these two up, it doesn't mean that much. You can't switch up the right angle. But you have to know that, oh, they're talking the angle is 48 degrees, and that the side adjacent to that angle is 13, and that they want me to find the hypotenuse. That's just kind of really important for this problem. Now we go back to where we started, and we kind of had a review of trig. And we said, okay, what do we have here? Well, oh, I have my adjacent side, and I have my opposite. I'm looking for my opposite side. I'm going to use tangent. So you just have to decide sine, cosine, or tangent. What are you going to use? So you'd say just tangent of 48 equals the adjacent over the opposite. And I'm going to say then C, when you're looking for the denominator equals 13 divided by the tangent or the trig function that you're dealing with. And the answer there is I would just get a calculator. In the calculator, I'd punch in 13 divided by cosine of 48. I got 19.4. Okay? So it's just about more, do you know where to put the different letters that they're talking about? And then once you do, how do we work it through? So the type of problems we're going to have here, and this is just the first two on the assignment that you're given, is listed here. There is a worksheet. It's called worksheet 5.4. It's mixed practice. It's a really good worksheet. I'd really think it's going to be important for everybody to get that done. So on the assignment here, let's just start you on how would you draw the picture for the first one. -2, 3, I would draw the picture like this. And if you remember, this one goes back to where you have -2 and 3. And then you have to find the hypotenuse. So you're going to say 9 plus 4, and that equals 13. Square root of 13. Looks a lot like one we did in this example. Here, you're going to stick with, oh, we're at the point 0, 6. And you're going to stick with your rules that x equals 0, y equals 6. Sine is going to be y, cosine is going to be x, tangent is going to be y over x, and then you kind of do the reciprocal. There's definitely going to be two values there that don't exist. And you can kind of remember, hey, on the y-axis, on that y line, it was secant and tangent that didn't exist, if you remember. So those are the two that are going to be, oh, it does not exist. Good luck.